actually do computations which are needed in physics or other science using the knowledge of computer science. So this is one example of the type of interdisciplinary work which I'm mostly involved, which is relatively easy. You have two well-defined fields, they come together. Now there is a very different interest I have, which is completely wild, completely broad and open, and I have no idea whether anything will come of it, but at least I'm interested in trying. And if you go back to the year 1600, that was the time that around 1600 Galileo started to use mathematics as a basis for science, as a basis for natural science. And he was using very, very simple mathematics and very, very simple experiments. So he combined his experiments. So he was dropping something or rolling something from a plane and checking how long it takes. And he could see that throwing something is a linear motion in this direction and a quadratic motion in this direction. And he got very simple relationships which he could put in mathematical form. And then you got Kepler, and you got Descartes and Huygens and Newton almost 100 years later could have a much more detailed mathematical formulation which was the basis of modern science. But without Galileo you could not have had Newton. So math was important and experiments was important. Well, what is an experiment? An experiment means you don't use only logic. Mathematics is based on logic, but an experiment means that you actually check your own experience. You check what happens in the real world, what you can see with your experience. So your experience is complementary to your logical thinking. But experiments being based on experience, what kind of experience do we allow? Normally, in any kind of experience, you have a subject, and then you have an interaction, and then you have an object. I see a piece of chalk, or I hold a piece of chalk, I touch something, you hear something, you tell me something. So there is always a subject doing something with an object. It can be input, it can be output, it can be sensory input, it can be actually doing something. But every structure in our experience normally has these three aspects. Now, what was important with Galileo and Descartes and ultimately Newton is that they came up with a way to be empirical. So empirical means that you base your knowledge on experiments, on your own experience in well-defined experiments. But empirical, as defined by Galileo, is that you treat the world in terms of objects, and you ignore the interactions and you ignore the subject. So what you do is that if 3 or 5 different people, different subjects, have different ways of testing the same object, then you say, now I have the scientific knowledge of an object. So, scientific knowledge. Scientific knowledge is knowledge about objects. And now we are so used to that, we cannot imagine a different way to do science. We cannot imagine to do science without taking our experience and analyzing everything in terms of atoms and molecules and objects in an objective way, which means in an interdisciplinary, subjective shared way, in which we throw away, of course we have to use the subjects, we use the interactions, the height is knowledge, and we only focus on here. So I think what Galileo did was 1/3 empirical. It was not really empirical, it was only 1/3 empirical, using only this part. And now the question is, now that we are 400 years later, in this century, what can we do? The question which I have posed myself is to ask, can we be fully empirical? Can we really study the totality of experience, also the subject and interaction, and not only the object? And normally we would say a psychologist does this already. A psychologist studies subjects and studies interactions. But what a psychologist does is there is a psychologist here, and a psychologist studies the subject and studies the interactions and studies the object as if they were objects. So the psychologist treats the subject like they put the subject in the laboratory, and for a psychologist the subject becomes an object, and the interaction becomes an object of study. So the psychologist does the same thing, taking only the object part. And actually most philosophers even do the same thing. They try to give a reason, metaphysical reason for why the universe as it is in an objective way. So the question is, can we be different? And you can ask why. Why should we try to do that? Well, let me give 3 reasons. 3 reasons to study the subject. And one reason is quantum mechanics. Another reason is brain studies, neuroscience. And a third reason is robotics. To make robots and to study robots. In quantum mechanics, we have learned that a single quantum cannot be treated like an object with an objective state. If you measure it in different ways, you can get different outcomes, which through the measurement you already change what was there, and what is worse, you cannot even have a single description of what was there even before the measurement. This is related to Bell's inequalities and stuff. We can't go in there right now, but clearly the ideal of science of Galileo, that there is one object, that independently of the subject and independently of an interaction, you can talk about the one object, that doesn't work in quantum mechanics anymore. People try to find interpretation which is sort of works, but I think that is wrong-headed. That's another discussion in itself. But at least it's not trivial to use objects. So quantum mechanics tells us we have to stop hiding the subject and the interaction. Brain studies are very clear. If somebody studies my brain, if I see a color and they study my brain, they don't see a color. They see an electric impulse and they see a chemical reaction, and I experience a color. So there is a translation between subjective and objective experience. So if you leave out your subjective experience, then you can only talk about electricity and chemistry. You cannot talk about personal experience. So there it really has to come in. And in a way, I find this the most interesting. Why don't we have good robots? Why are there only people in this room and there is not a robot cleaning the room or something, or making tea or bringing us tea or something? If you read science fiction of 50 years ago, then no science fiction would predict that we have a computer in our room. But everybody had many robots in their room in the year 2000. Robots were cooking, robots were cleaning, robots were serving you in many ways, but computers were still seen as something very strange. But instead, in the last 50 years, everybody has a computer on their watch, in their camera, in their pocket. But where are all those robots? We know how to build a robot, the hardware is not difficult, but we don't know how to program a robot. And I think the reason that we don't know how to program a robot is simply that we don't understand what a subject is. We have 400 years of science to analyze objects. We have 1 million years of making tools which are objects. The first tools, the first arrows, the first flintstones, they're all objects. A computer is an object. It has some autonomy, you can program in it, but as a thing, it is an object. But a robot is a subject. A robot is autonomous. It moves around, it can do its own thing. And I think because we don't know it, therefore we have such difficulty programming it. So I think there is a real practical application to building better robots. There is already one motivation to become fully empirical and to include all three aspects of experience. Now the question how to do that, that's of course a very big question. And just like it took 100 years almost from Galileo to Newton, I don't think there will be somebody who suddenly says, oh, this is how you do the science of a subject. That would be impossible. I think during this century, more and more people will come up with little bits of ideas here, little bits of there, ideas there, and there will be a few geniuses maybe who have a bigger idea, but many other people with smaller ideas. And maybe in 100 years we can get something like the science of a subject. And my guess for a place to start is in what is called phenomenology. Phenomenology is a word which is it's a word which is too long, it's hard to remember. Phenomenology, yes. Gensho kaku, Nihongo de. So it's the study of Gensho, of phenomena, the study of what appears. So you don't study what you theoretically think is the case, but you start with what really appears. And what really appears has a subject interaction object structure. By the time you treat it like objects, you are away from the Gensho, from the phenomena. You are already in theory. So we have to go back to a more primitive way of dealing with our experience. And this is what Husserl started, the philosophical school of phenomenology is what Husserl started. And he was active in phenomenology somewhere between 1900 and 1939 or so, I believe that he died. In this period, he did quite a bit of work and he stimulated many other philosophers. But he was Jewish, he lived in Germany, he was put under house arrest by the Nazis and his followers were sent all over the place. So for historical reasons, his school didn't continue, which is really a pity. And many ideas in modern philosophy come from Husserl, but many people don't even know that. So I would like to use some of these ideas and see what we can do on this level. And I'm talking with several people in this area. For example, in Riken, in Tokyo, in Wakoshi, there is one robot expert. He has his own lab. Tani Jun Ichiro, I think is his name. He has his own laboratory, and he has written a few papers in which he quotes Husserl and Heidegger, phenomenologist. And the other robot expert thinks that he is just crazy. He has this strange hobby. He's doing good work, but he has this strange hobby about phenomenology. But I heard about him a few months ago, and then I started talking with him. And I think that maybe we can actually get somewhere by getting him and me and some other people to talk, including some professional phenomenologists who are interested enough to talk about applications. So there is a real possibility that something interesting can come out. Saigo-san, can I say that you're involved too, or is that secret?
Would you say that?
I won't say it. Saigo-san is one of the real broad thinkers here too, who is also interested to some extent in these topics. And he has come up with some interesting suggestions of how to use category theory for thinking about an object as generated by interactions to subjects. If you think